Starts.
Good morning, students. Today we are going to see a title about laboratory biosafety. So, laboratory biosafety is a very important concept which is very much mandatory for biomedical science scholars as well as biomedical science master students. Hope this lecture will get some information how to behave yourself in the laboratory and what are the precautious methods we have to observe and while working in the laboratory. Now we'll see the slides. So this slide is simply showing the common research materials which is used in the molecular biology lab. This is very familiar thing. This is a bacterial culture plate. That is a fungal culture. This is the microbial culture involving in the human blood samples. And the next one is in the human serum. So these are some of the common research materials. Continuation of this slide. These are the other things which is used for molecular biology lab. There are different kinds of cell lines, transformed cell lines, and culture plates, virus cultures, and transgenic knockout animal models, knockout animal models, and the aerosol challenges with the infectious agents, which may be can be used in the biosafety level, 3 or 4 categories. Next. And here you can see the picture, which is it may look very awkward, of course. If you keep in these plates for quite a long time, and you can show us some kind of ugly faces like the whole petri dishes with the growing colonies of bacteria and molds. So unknowingly, if you keep this kind of cultures for quite a long time in laboratories, sometimes it will cause some harmful effects to the people who are working in the laboratories. Like the pseudomonas infections, it can cause in the eyelids and in your feet, and the staphylococcus can make an boiling skins, and fungal infections can also cause some severe effects in your feet. So these are some of the occupational transmission, like when you use the broken glasses in the laboratory, sometimes it may harm your fingers and can make some injuries. Also, if you have any injuries in your skin or your hand, like anywhere in your body, so if you're not taking the proper care and so the same kind of broken skin, if you come across to work in any laboratory hazardous materials, it may cause some severe damage to your body. And sometimes when you transfer the chemicals from one bottle to another bottle, it may cause some splash, so sometimes you get some infections, as well as some noxal infections and mouth infections too. So these are the operation and the possible hazards that are given. Reuse can cause an accidental evacuation, and centrifugation. Sometimes if the limbs are not properly closed, it can cause an aerosol and splashes, and tube breakage also it's a quite common thing. And water pots and culture media and dishes. So if you are not changing it properly in water in this equipment, so you can facilitate for growing microorganisms, can cause some unwanted effects to your health. These symbols may be very common symbols for you people. You could have seen these symbols in many sites of the laboratories. These symbols simply shows there are some biohazardous things or heterogeneous very close to you. So whenever you come across to see these kind of symbols, you should be very cautious. Either it can be microorganisms, allergens, or toxins. So the biosafety, the applications which combines the combination of the practice and procedure of the laboratory and the lab facilities, the safety equipments. This is very much essential for the who are working in the laboratories, like co-workers and workers and lab supporting personnel, and the products, whatever you are preparing, and the environment. So that's very important. So the principles of biosafety is contain the laboratory practice and procedures and biosafety levels. So laboratory practice procedures, it has two things, like standard practices and special practices. So biosafety levels, if you talk about biosafety levels, there are biosafety level 1, 2, 3, 4, there are 4 levels of that, and the increasing levels of the personnel and the instructions, so it is categorized in the four numbers. So safety equipment is talking about the primary values, and the facilities, design and constructions is talking about secondary and tertiary values. So about practices and procedures, now we can see what are the standard practices and special practices. So these are the universal precautions. Handle all biological samples with caution. So this is very, very important when we are working in the laboratory. And also carefully handle all unfixed tissues, primary human circulation and other potentially infectious materials. So these are the universal precaution things. Next. And these things has to be strictly followed in any laboratories, like eating, drinking and smoking, which is not permitted in any laboratories, as well as the mouth pipetting and food storage like chocolates in the refrigerator, and while working with the concentrated acids, better please avoid using contaminants. Next. And these are some of the standard microbiological procedures and practices, like it is always advisable whenever you done with your work or before you start your work, it is better wash your hands with the soap solution. And this also another very important things. It is always advisable to use a mechanical pipetting device instead of using a mouth pipetting. So these are some of the mechanical pipette devices which is available in all laboratories. Next. And the lab coat, wearing the lab coat and wearing gloves is very much mandatory for working in any laboratories. Next. And also using personal protection equipment like the goggles, and also very advisable when you are transferring solution from one bottle to other bottle, also whenever you are weighing any concentrated salts and acids. So face protections and eye protections can be ensured by using these personal protection equipment like this goggle. Also, whenever you are done with your work by using this needles and syringe, and you should use a proper needle cutter, and by the way you can ensure the proper disposal of all needles and use the syringes. So it cannot be recycled again, sorry, it cannot be used by other people. So if you are not disposing it properly, if you try to trash the needles and use the syringes in the normal trash, so it may form sometimes in the lab personnel or the lab supporters who is cleaning all the materials in the lab. So it is always advisable to not to discard this kind of things in the general trash. Also, whenever you spill any biological materials like blood samples and serum, it is always advisable to first alert your co-workers and immediately clean that place by using any cardboard, such a simple cardboard which is available around your lab, and also clean that place properly with the disinfectants. Also, always it's advisable to use plastic guns instead of using glass containers, so it will minimize the chances of breakages. So leak-proof containers will be very helpful when we are transferring any biological materials from one place to other place. So, so that those conditions, it's very much mandatory. Also, the biohazard bags and bottles, you should make a habit of using this in the laboratories. Next. So these contaminants work surface daily and after spill of any biological materials. Also, the decontamination of all biological waste, like whatever things which are using in the biosafety one, before disposal, like any polymer plates, that we can go for an autoclave and put it into the dumpster, then you can dispose it properly. On liquid waste, better you can add a bleach, like a 10% bleach. It's quite enough to disinfect all the biological materials. So these are some of the decontamination methods and their effectiveness. If you look at this, there are low level decontamination, intermediate level, and high level, heat sterilization method. So there are basic microorganisms that are given in this slide. So each of these microorganisms can be decontaminated by different levels by using the different decontaminant methods. So these are the different biosafety level biosafety levels, like the BSL1, BSL2, BSL3, BSL4. So BSL1, its agents known not to cause any diseases. This is a BSL1 laboratory, which is available on all universities, a very common one. BSL2 agents associated with the diseases, and BSL3 is an indigenous and exotic agents which is associated with the human disease and the potential for aerosol transmission. So BSL4 is a very much dangerous and exotic agents of life-threatening nature like Ebola viruses. So the microorganisms that don't consistently cause diseases in the healthy adults can be moved under the category of the biosafety level 1. These are some of the examples. Next. This is the typical biosafety level 1 laboratory lab. This is secondary procedure with barriers. And biosafety level 2 can be handled the microorganisms and cause a moderate potential hazards and transmitted by contact, ingestion, and puncture. So these are some of the organisms can be handled in biosafety level 2 laboratories. Next. So the biosafety level 2 laboratories, where they can use standard microbiological practices as well as some of the special practices like training and handling pathogens, access to the lab limiter, and extreme short precautions, and use of biosafety cabinets for aerosol. So these are some of the special procedures has to be followed in the biosafety level 2. So these are biosafety cabinets are mostly used in the all biosafety level laboratories for protection of the personal and both the environmental. So these are the typical secondary structures of the BSL laboratory. So risk assessment wise, you can see the pathogenicity of material, like the disease incidence and severity, and routes of transmission, whether it's parental, airborne, or ingestion, and the agent stability, like the frequency of decontamination, the infectious dose, the LD50 value, the concentration, whether it causes an infectious organisms, the particular volume, what is the working volume. So this is supposed to be known on origin of material, whether it's a wild type or exotic or a primary cells. So these things should be in limits. We should aware about before we work on the particular agents, and availability of the applicable prophylaxis. Like if you're happen to work in hepatitis B viruses, better you should go for a hepatitis B vaccination. And medical surveillance, the exposure management, and skill level of staff. So these are some of the main risk assessment procedures we need to follow. Accidents and response. So we have to think very carefully in all angles before we plan our experiments and take precautions, and we should be remain alert whenever you are working in the laboratory. Emergency response, the personal contaminations. So we should alert the co-workers, and we should clean the exposed surfaces with the soup water, or if you happen to expose with any aerosol or splash things, and we should wash our eyes properly, and apply first aid and treat an emergency, notify supervisor and security desk, and you have to consult your personal doctors for the proper precautions for the medications. So surface contamination also should be, you should alert your co-workers and define the contaminated area, and you should remove all the glass or lamps with the forceps or scoop, apply absorbent sheets to spill, and also apply to disinfectants in the surface to allow the adequate contact time, maybe 20 minutes or so, and also mop up with the seat and clean with the ethanol. So the proper disposal of materials is very much mandatory, and this is always advisable. Whatever happens, you should notify your supervisors. So the chemicals, before we work on any chemicals, we should look at the chemical compositions, the expiry date. So these things has to be noted properly. Also, the following chemicals are particularly noteworthy, and phenol can cause severe burns. Acrylamide, it's a potential neurotoxin. We should not touch acrylamide with our hands. ethylene level, as I said before, it's in a carcinogenic nature. Ultraviolet light also we should not view ultraviolet in our normal things. We should wear UV protection goggles. So by the way we can protect our eye from the UV damage. Next, electricity also, whenever you are working with the thin electrophoresis, the lid has to be properly closed, or also make sure that whether the current is passing or not. Next. So these are some general housekeeping things. Keep your own area clean. When we use in common facilities, all solution everything stored in an incubator, refrigerator, and must be labeled. And unlabeled material found in refrigerators or incubators or freezers may be destroyed. Mark the backs of the plates with your initials, date, and 11 experimental data. For example, strain numbers. If you happen to store your strains in the minus 20 degrees, you should make it properly the strain numbers for these data. These are some of the biosafety literatures which is available for your reading purpose, can be seen in the websites too. And also these books are available in laboratory reading as well. So study this literature properly and keep your workplaces and biosafety workplace. Thank you.